Okay, another look at some of our most important things to do with chemistry. Now, in all chemistry, we rely on the fact that the conservation of mass law is totally obeyed. And this simply tells us that the atoms going in and the atoms we end up with are the same and have the same numbers. I couldn't resist putting this little joke in at the start about chemistry is like cooking. Just don't lick the spoon, and that's obvious when we think about all the chemicals we mix. But it is true. You must put exactly the right number of each individual atoms in to get the right product. And that sort of becomes a little bit important in our calculations and what we are doing. So I think the first thing we need to do is to look back at what we already know. And in other words, let's review what we know. Reactants are obviously what we start off with, and products are what we make in any chemical reaction. But the one important thing to remember is that atoms have mass. As we'll see when we delve into atomic theory, the mass of each elemental atom is different. And that's because it has different particles inside of it, or different parts, if you like, and that makes up for this mass. Now, leading on from that, we see that the more atoms that are present, the greater the mass that exists. And this is why we tend to not rely upon just simply mass when we are comparing reactants and products, because we are looking at different atoms and we're looking at different combinations. So it becomes a lot easier to think of moles first as our comparative tool and work from there. So this leads nicely into the law of conservation of mass. Note that I say law, and that simply means that it is correct always. So we can always assume it's going to be correct, and we always just simply say, right, that occurs, therefore we must balance. Now, it's a bit different to when we're talking about physics and other things, but in terms of chemistry, you must remember that atoms, in a chemical reaction, atoms cannot be suddenly plucked out of the air or created, and they cannot be destroyed. There is no transmutation going on. All we do is we play a game of Lego. We dismantle all the atoms, take them right apart so they're in single atoms, and then we put them together in a different pattern or rearrange them. And this is the whole premise of what happens in a chemical reaction. Probably the best way for us to look at this is if we consider a real life situation. So what I've done here is I've given us a situation where we are combining magnesium with oxygen in the lab. Now we know that magnesium is a solid in the lab, and we know that oxygen is a gas, and the product magnesium oxide is also a solid. So I better put the all-important arrow in, because the arrow means basically is changed or rearranged into to form. Now we can see, to match it up, we look at the correct formulas, and we know the correct formula for magnesium oxide is going to be MgO because of combinations of things. So what we do is we look at it and we see that it's there. So we know that oxygen gas occurs as O2, which is here. So this means we've got two oxygens here, but without the two in front, we've only got one oxygen here. So to make two oxygens here, we have to put the two in front of the whole lot. So now on the product side, we've got two oxygens and two magnesiums. So on the reactant side, we must have the same atoms. And so now we've got the two oxygens, which is how it occurs naturally, so we have to put the two in front of here, and that successfully balances our equation. Probably the best way forward for you here is to practice. Equations are tested, right? And it's most important that we can do it. So if you're doing equations, make sure they are correct. So we must make sure our formula are correct, and that again is practicing only. What we're going to be asked in test questions are moles calculations, and they rely upon you having correctly balanced equations.